In section 10.6, the first thing we're going to try to do usually is get the square root quantity by itself. We're not going to undo things inside the square root. We're not going to undo the plus 5 with a minus 5, for instance. But we can undo things that are outside of the square root. So we can add 4 to both sides, for instance. And then a new idea is that we can multiply both sides of the equal sign, the left-hand side times itself as many times as we want. In this case, 2 would be very convenient. And then we multiply the other side by itself the same number of times. We can do this as long as we understand that when we multiply the sides times themselves, we have to do a check. We have to check our final answers. It's a mandatory check. Here, a square root times a square root gives the thing inside when they're common square roots, and here we have 25. Subtract 5 from both sides, and what we find out is if this equation has any solutions at all, it's 20. But the question is, does 20 work? And we have to try it out to find out. So we put in 20 in place of y in the original problem. And we ask ourselves, is this true? And this is the positive square root of 25, that's 5. Does 5 take away 4 equal 1? Yes, it does, and so 20 is the correct answer. Notice at this point, if you're going to a tutor, for instance, you'll likely be told something like this. Well, yeah, you could do this, but nobody ever does that. In fact, what they do is they square both sides, because you can square both sides. And it's true, you can square both sides, and what you'll get is exactly this. Squaring both sides is the same thing as doing what we did here, but this leads to understanding, whereas sometimes this doesn't lead to good understanding. It just depends. So my advice is do it this way until you can't stand it anymore, and then give yourself the option of doing it this way. Either way, though, the rest of the work stays the same. Here, the cube root is already by itself, and so we could, if we wanted to, start the problem this way. We're going to multiply the left-hand side by itself 3 times. Why is that? Because we have cube roots, and it takes 3 of them multiplied together to get the thing inside. And so we're going to have a regular y plus 3 here, a regular 8 here, subtract 3 from both sides, we get a regular 5. If there is an answer, it's going to be that, so we ask ourselves this question. Well, let's try to write it 2 a little better than that. I still haven't gotten control of this pen. Does the cube root of 8 equal 2? And the answer is yes, that checks, and so 5 is the solution. By the time you're working on equations that have cube roots, often people then graduate towards writing the second step this way. Instead of multiplying the left side times itself 3 times and the right side times itself 3 times, just put a cube. And then you'll know, evidently, that a cube root cubed is the thing inside. And you'll know 2 cubed is 8, and off you go. You're right here. That's an option. You can use it. This produces understanding that this sometimes does not produce. Be warned. Here we're going to multiply each side by itself, 3t plus 4 times the square root of 3t plus 4 equals the square root of 4t plus 3 times the square root of 4t plus 3. This is, of course, 3t plus 4. This is, of course, 4t plus 3. Subtracting 3t from both sides and subtracting 3 from both sides. I get t on this side and 1 on this side. So I think t equals 1 is the solution. A quick check by putting 1 in for t in the original problem gives us 3 plus 4 underneath the square root on the left, and 4 plus 3. And are those 2 equal? Yeah, they both equal the square root of 7. So this checks, and we're done. In the original equation, we'd like to get both square roots by themselves, then it would be like the last problem, which was not too bad. But if we get one square root by itself, the other one isn't by itself, and that's just the way it is. So we're going to have to multiply each side by itself, and that is kind of difficult. So be careful with this process. There will be a problem like this on the exam, so study this and think about it and try it. On the left-hand side, we have a root times itself, which just gives us the thing inside, which is very convenient. On the right-hand side, we have a mess. We have FOIL, in a sense. We got 2 times 2, that's 4, plus, and we got 2 times this square root. And then we got another one of them. That's 2 times this square root plus. And then we got this times this. So we have 4x minus 3 equals 4 plus 2 of these roots plus 2 more of those roots is 4 of those roots. Plus a root times itself is the thing inside. 4x minus 3 equals 4, take away a 5 is a minus 1, and then we have our plus 2x here, and then we got plus 4 square root times the square root of 2x minus 5. Adding 1 to both sides and subtracting 2x from both sides, we get 2x minus 2 equals 4 times the square root of 2x minus 5. There's a bunch of things we could do at this point. I'm going to choose to divide both sides by 2, just because it makes things smaller. This 2 distributes to the 2 2's, and I get x minus 1. And this is just a 2. Why didn't I divide both sides by 4 to try to get rid of that 4? Well, then I'd get fractions on the other side. I don't really want fractions in this problem, and I really don't like the looks of my x either. So now, the only thing to do is to multiply both sides times themselves again. And that means this is definitely a Math 89 problem. This is no longer a Math 29 problem or a Math 30 problem. This is second semester algebra for sure. Over here you do FOIL, you get kind of 4 terms. You get x squared minus x, which is minus 2x plus 1. And over here you have 4 times 2x minus 5, because 2 times 2 is 4, and root times root is the thing inside. So distributing, on the right hand side we have 8x's minus 20, subtracting 8x from both sides, adding 20 to both sides, we get, and I'm going to bring it up here on the right hand side, we get x squared and minus 10x's plus 21 equals 0. Factoring, we have x minus 3 times x minus 7 equals 0. So x minus 3 equals 0, or x minus 7 equals 0. Add 3 to both sides, we get x equals 3, or add 7 to both sides, we get x equals 7. I think those are the answers, but they must both be checked in the original. If I put in 3 here and here, I get the square root of 9 is supposed to equal 2 plus the square root of 1. 3 does equal 2 plus 1, so 3 checks. If I put in 7 here, I get that the square root of 25 is supposed to equal 2 plus, putting in 7 here, I get 2 plus the square root of 9. 5 does equal 2 plus 3, that's a check. And so both of these are solutions, and that's a pretty tough problem. I suggest that you practice it a few times before our next exam, because you can do this, but it takes some practice.